So we want to determine the slope of a line that contains the points 8, -1, and -3, 5. So our slope formula is m equals y2 minus y1 all over x2 minus x1. So we plug into our formula. We have -5 minus a -1 all over -3 minus 8. And we would get, using our arithmetic, plus positive, and that would give us -4 over -11, which is 4/11ths. You can also just type that directly into your calculator. So if you go alpha y equals to get your fraction, you can just go -5 minus a -1 over -3 minus 8, and it will tell us the exact same thing, which is 4/11ths, right? So I know you guys know how to do a bunch of this stuff by hand. I just want to remind you how to use your calculator and other technology to resolve a lot of these problems. So what I'm really trying to tell you is, if you can use technology to do it, do so. Don't do it by hand, because we have enough other things to do that we don't need that. All right, it's now your turn. So take a second. We got a quick try. All right, so remember in function notation that this part right here inside the function notation is our input, so that's usually our x, and this part out here is going to be our output, which is usually going to be our y. So if we were to find our slope, we would get our fraction, and we're going to have 7 minus 7 all over 6 minus a -4, and that should give us 0. So our slope is m equals to 0. All right. Example 2. We want to do the same thing that we just did. So let's go ahead and calculate our slope. So I do my m, I have -5 minus a -1 all over 8 minus 8. I'm going to work this one out by hand, so plus positive, so -5 plus 1 is -4 over 0. Well, we're not allowed to divide by 0, so this is undefined. So what we actually had happen here is, if you were to do a quick sketch of our graph, we'd be out here at the point 8, we'd have -1 and -5. This is actually the graph of a vertical line. So our slope is undefined. So vertical lines always have undefined slope. Horizontal lines have slope m is equal to 0. So in the previous example, you guys found the slope, and what was our slope? 0. So the line would have been horizontal. If you ever end up with a slope that is undefined, it means that the line was actually vertical. So it goes straight up and straight down. All right, so let's go to example number 4. So determine the slope of the line. So to determine the slope of a line, we just need to recall our formula for the slope is the change in y over the change in x. We'll abbreviate this as delta y over delta x, where the Greek letter capital delta, this little triangle, is an abbreviation for the change in. So if we were to calculate our slope, we just pick 2 points, and if I do so, I would count them off by making a triangle and doing this. So to go from here to here, I went down 2 units, so that's -2, and from here I went to the right 1, 2, 3, 4, 5 units. So my slope, m, would be my change in y is -2 over my change in x is 5, and I get -2/5. It's worth noting, regardless of the points that I use to calculate it, so if I were to say start here and go this way, I would then go up 1, 2, 3, 4, and then I would go left, so that's -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, -10. So my slope would be 4 over -10, which reduces to 2/5, which is exactly the same thing that I got here. So regardless of how I count these off my graph, my slope will always be the same. All right, I want you guys to go ahead and determine the slope of this line. All right, so we pick a couple of points. I'm going to go here and here. So I go 1, 2, 3, 4, and 1, 2, 3. So my slope is going to be 3/4.
Professor?
For our next example, we're just remembering that formula that we mentioned in the previous section. So y equals mx plus b. So the m is our slope, and that's what we're asked to find. So we want to determine the slope, so we're really just comparing this to y equals mx plus b. So in this case, the coefficient on the x's are m, so our slope would be positive 6/7. So once again, we just compare it to y equals mx plus b. And we find our m value, so our slope is -0.35.
Excuse me?
Yes.
So are you saying, like...
So now we want to find a linear equation whose graph is a straight line with the given properties. That should have an m. M equals -2/3, and the y-intercept is 0, -4. So our equation of our line is y equals mx plus b. That's still our slope, and the b is the y-coordinate of the y-intercept. So in other words, it is the point 0, b. So if I have my m is -2/3, and I have my b is the y-coordinate of the y-intercept, we have this, we can assemble our equation by just putting each of those parts in. So we get negative 2 over 3 x plus our b value, and in this case, it's going to be, since it's negative, we'd change it to negative 4. So that would be the equation of our line with slope negative 2/3 and y-intercept 0, negative 4. All right, let's do our next example. Builds on what we were just doing. Example 6 is an example of the easiest type, but more often than not, we are asked to find a linear equation, and we aren't given its slope directly. We're just given some points. So then we would need to use our slope formula to find our slope. So we would have m is equal to 7 minus 0 over 2 minus a minus 3, which would then give us, we have a minus is plus, or you can just type all this into your calculator. We get 7 over 5. So that would be the slope of this line, and then neither of these points are the y-intercept. We don't have a point of the form 0, comma b. So we weren't given the y-intercept. So since we don't know, we must calculate it. So we do know our slope, so we have y equals 7 over 5x plus our b, which we don't know. But we do know either of these points, so we use one of the points to find b. So I'm going to pick this point for no other reason other than it's listed first. So I put that into my equation, so I have 0 is equal to 7 over 5 times my negative 3 plus b. And when I do this, now the only thing that I don't know in this equation is b. So I have 0 equals negative 21 over 5 plus b. I add 21 over 5, and I add 21 over 5, and so I get 21 over 5 is equal to b. I now take that b value, and I'm going to put it back into the equation with the slope, giving me my final solution to the problem. So my y is equal to 7/5 x plus 21 over 5. And that would be the equation of our line that contained those 2 points. All right, and so to do example 8, we want to graph the line x minus 2y equals to 8. So there are several ways to do this, and we'll also talk about how to do it with technology. If we were going to do it by hand, there are 2 different methods. We can either find the intersects or the intercept method, or put it in the form y equals mx plus b. So I'm going to focus on the y equals mx plus b method. So we minus x, we minus x. That would give us negative 2y is equal to negative x plus 8. And we divide by negative 2, divide by negative 2, and divide by negative 2. So y equals, a negative divided by a negative is positive, so negative 1/2 x. And 8 divided by negative 2 is negative 4. So we could then identify both our m and our b. So our m value in this case would be 1/2. And our b value would be negative 4. So now we know that b is the y-coordinate of the y-intercept. So it is the ordered pair on the graph, 0, negative 4. So 0, negative 4 is here. And then if we know our slope is 1/2, that tells us we go up 1 over 2, up 1 over 2, up 1 over 2. And then we just play connect the dots. And that gives us a nice graph of our function. Also, after we've converted it into this form, we could just put it into our calculator. So if we put in our y equals, let's clear out what we have in here. We have negative 1/2. Oh, sorry, not negative. It's positive 1/2. So the 4 is negative, so 1/2 x. Take away 4. We can go graph. And my window's all messed up because I've been messing with it, so I press zoom and choose choice number 6 to get back to the standard 10 by 10 grid. And we get a line that matches up what we thought. If you wanted to check some points, press your second and your graph button to get your table, and we can go look at some different values. So when we were at 0, we had negative 4. Looks like out here at 6, we should have negative 1, which indeed we do. So our calculator creates a nice numerical table that can help us plot points or analyze things as well.